Dear students, Assalamu alaikum and welcome back to Plant Physiology course. In these videos, we have been discussing thermodynamics, the laws of thermodynamics, various concepts related to thermodynamics and energy. Now in this particular video, we are going to take a look at the types of energy that are available. Since we are talking about energy, the Gibbs free energy, so let's see what kind of energy or what kinds of energies are available and which one of them is of interest. That is the one that we need for our formal or appropriate diffusion definition. So the types of energy, they are different, like electronic, nuclear energy, rotational energy, vibrational energy, and finally the translational kinetic energy. Translational kinetic energy. As far as the first kind is concerned, we have written here 5 kinds of energies: nuclear, rotational, vibrational, and translational kinetic energy. So these are 5 different kinds of energies. The first one, the electronic energy, it is related to electrons. And for the time being, it is of little interest as far as our process of diffusion is concerned, because electrons have their energy, and according to their energy, they occupy a specific or particular orbital in the atom or in the shells of the atom. And when an electron receives extra energy, it may jump to a higher energy orbital, and it may or may not get its spin reversed. So that is electronic energy. And electron excitation, it is of interest to us, and we shall discuss it, the excitation of electrons, when we cover the chapter on photosynthesis. But since we are concerned with the process of diffusion, we are interested in diffusion, so we are going to ignore it for the moment, the electronic energy or the energy of electron. Next is the nuclear energy. It is also for the time being not of great interest for us. And this energy, it is related to the atomic nuclei. So obviously we are not interested in it, and what kind of energy it is or how we can get it, for the time being we are going to ignore it. But when we deal with molecules, atoms and ions, these two energies, the rotational and the vibrational energies of the molecules, they are of special interest to us. Rotational energy is the energy of the atoms in the molecules, in which atoms, they rotate around each other. And vibrational energy, as we know, this is the energy of the atoms in the molecule in which they vibrate. That is, atoms moving away or towards each other in the molecule. So this is vibrational energy. It is important as far as our consideration of diffusion is concerned. But what's more important, or the most important of these five kinds of energies that we have been discussing, the final one, or the translational kinetic energy, is of special interest, and this is what we are going to consider as far as the process of diffusion is concerned. So, translational kinetic energy, what is it? The movement of molecules in straight line. So, this is suppose an atom or a molecule. So, its movement in the straight line, and it can be in any direction. It depends upon the medium or the place where this molecule is found. So it is a random movement of the molecule, and this particular energy is actually the driving force during the process of diffusion, as the molecules diffuse from, as we have seen in the very conventional and the age-old definition of diffusion, the movement of molecules from their region of higher concentration to their region of lower concentration. So this movement of molecules, it is driven by this particular energy, what we call translational kinetic energy. So as we have seen, there are various different kinds of energies, but the most important for us as far as the diffusion is concerned, it is the fifth type, the translational kinetic energy. As we know, this translational, it means in straight line, linear motion. This is what we call translational kinetic energy. As we have already seen in one of the previous video, the kinetic theory, that all the molecules or atoms or ions, they are in a continuous motion, whatever their nature of movement might be, but they are in a continuous motion. And of special interest is this one, the translational kinetic energy, that is above absolute zero, and that is 0 degree K. Above absolute zero, or minus 273 degrees Celsius, the molecules move, and they move in different direction, and these directions depend upon mostly with their collisions with other molecules. A molecule will continue to move in a straight line, but when they collide with other molecules, or if they are confined in a container and when they strike the walls of the container, they bounce back and then they start moving in another direction. So this is translational kinetic energy. Here is the definition of diffusion based on the energy considerations, especially the translational kinetic energy. So it's the same definition, almost the same, that is the movement of molecules of a substance and from its region of high concentration to a low concentration, and as a result of what? The random translational kinetic motion of molecules, or it might be ions or atoms. So now, after discussing the laws of thermodynamics, after considering various aspects of the energy or the Gibbs free energy, now we can understand the process of diffusion in a better way. And this particular definition, although it is not perfect or very good, but still it is much better than our previous definition, and tells us that why molecules are moving from their region of higher concentration to a region of lower concentration. So this is one definition of diffusion, and let's move on further and considering the states of the free energy, the initial and now from the standpoint of Gibbs free energy, when the diffusion starts or when the diffusion is about to start, so this is the situation. We have a high level of free energy, that is G1 is at a higher state, and the molecules start diffusing to their region of lower concentration where we have a low G, and this is G2. So initial state is at a higher level, and then we have a lower energy level, that is G2 is lower than G1. So we have an energy gradient, and the molecules are moving along an energy gradient because G2 minus G1 is equal to delta G, but with a minus sign, and this minus sign is indicating that this is a spontaneous process and there is a net loss of energy. Although the initial and final states concept of the Gibbs free energy is helping us in understanding the process of diffusion, but now we have come to the point where we are going to refine our definition of diffusion, and we are going to make a final and more appropriate definition of the diffusion. Instead of using the word concentration, we are going to use here a more meaningful term, and let's see what's that, and that is chemical potential. So instead of using these terms, the initial state and the final state of the energy, G2 and G1 and the delta G, we use a very valuable concept in plant physiology when considering plant-water relations, and that is chemical potentials. So first, let's define the chemical potential, and then we are going to make the refined or the more appropriate definition of the diffusion. As I just stated, that instead of using the initial and the final states of the energy, we are going to equate the amount of energy to a given amount of a substance, that is a particular amount of substance, how much energy it contains, and this is what we call chemical potential. And here is the definition of chemical potential. So what is chemical potential? It is the amount of what free energy. This is present in gram molecular weight of a substance. The amount of energy that is available, the free energy that is available per gram molecular weight or mole of a substance. As we know, gram molecular weight is a mole of a substance. So this is what we call chemical potential. And this is a very useful term and very meaningful term as far as our definition of diffusion is concerned. So let's define and make a final definition of diffusion, and then we shall proceed further to other concepts and the actual concepts of the plant-water relations, that is osmosis, water potential, osmotic potential, and so on. So this is the definition of the diffusion, for which we have come so far and worked so hard, defined various laws of thermodynamics and concepts of energy, and finally we have arrived at a very suitable, appropriate, and a better definition of diffusion. And what it says, again, it is a movement of molecule, net movement of molecule, again from their area of high what? Now this time it is not concentration, it is the chemical potential. So movement of molecules from their region or area of high chemical potential to into another area where their chemical potential is low. And why they move? This is because of the random translational kinetic motion. So this is the definition of the diffusion for which we have worked so hard. So it is the again, it is a net movement of molecules. It is from a region of higher chemical potential to a region of lower chemical potential. So as we have seen, that concentration was not a very meaningful term. Concentration was not a very appropriate term, and it was not telling us anything about the actual process of diffusion or the underlying forces or the underlying processes that make diffusion possible. So this concept of chemical potential, it explains the process of diffusion in a much better way. So now we have a high chemical potential instead of concentration, and instead of using those initial and final states of energy, we now have a better concept at our disposal to explain these processes like diffusion and osmosis. So we have high chemical potential, and this is low chemical potential. Again, what is chemical potential? We know it is the free energy. In other words, the amount of free energy in given weight of a substance or given quantity of a substance is higher at this particular location, and it is low since energy is high in this location and low, and the molecules will move from their high free energy or high chemical potential to a low chemical potential. So this was the process of diffusion, a better definition of diffusion, more about diffusion and various factors that affect the diffusion and osmosis and other concepts in the coming videos. So thanks for watching and see you in the next video.